Hello friends, welcome in the next lecture of several variable calculus. So in the today's session we have to discuss the limit of a function of two variable. So our topic is limit of function of two variable. So if you try to remember, or if you memorize, in the last year also we discussed the limit of a function of one variable. Just we revise this limit of function of one variable, and we are discussing again a real valued function. So what we can say that limit x tends to a, f of x is equal to L. Limit x tends to a, f of x is equal to L. When it is possible, what is the epsilon delta definition? If for a given epsilon greater than 0 there exists a delta greater than 0 such that what we can say that 0 is less than mod of x minus a is less than delta, then what we can say that mod of f of x minus L is less than epsilon. So we discussed already this definition. What is here? For every given epsilon greater than 0, for every epsilon greater than 0 or given epsilon greater than 0, there exists a delta greater than 0 such that mod of 0 less than mod of x minus a is less than delta, then we can say that mod of f of x minus L is less than epsilon. And what we discuss here, what is this? Suppose this is our real number line and this is our point, this is our a. Then what we can take? This is nothing but what? X minus a, mod of x minus a means what we can say that this is the neighborhood of a on the real line. That is, it contains set of all points having distance is less than delta. Distance is less than delta, but not 0. That means what? It does not contain a point A. It does not contain a point A, and we can say that it is a deleted neighborhood. Deleted neighborhood, that means it number or point itself, it is not contained in the interval, but it this set deleted neighborhood contain all the points nearby A but not A. Nearby A but not A, that is neighborhood of A. And this is deleted neighborhood, and if you remove this is neighborhood of A. Is it? Or if it is only x minus a is less than delta, then distance between the point and this may be 0. That means this itself a number may be contained. But here is a distance 0 is not possible. That means what? This point is not in the neighborhood. Similarly here again f of x and L, these are the two numbers. Again it is the neighborhood of L. It is the neighborhood of L. What we can say that it is the distance between the, that is, it is the set of all points having distance less than, all points and L having distance less than epsilon. That is, if you see the diagram for this, suppose there is any curve like this, there is any curve, and suppose this is my x is equal to a, this is my x is equal to a. What definition tells us? What definition tells us? Suppose this is our L, this is our L, is it? So take any epsilon, take any epsilon. What it means? This is L minus epsilon, L plus epsilon, L minus epsilon, L plus epsilon. How it is? How it is if you solve this like this? So what will be? Minus epsilon is less than f of x minus L is less than epsilon. And what it implies? What we can say? L minus epsilon is less than f of x is less than L plus epsilon. And what it implies? This is nothing but f of x belongs to the L minus epsilon, L plus epsilon. L minus epsilon, L plus epsilon. What it means? Take any suitable or given epsilon, given epsilon, it is condition on, that is you can take any epsilon, and then what definition says? If this function has a limit, then for every epsilon, is it? That is, for every epsilon you get a corresponding delta, that is x minus delta, that is x minus delta or a minus delta, a plus delta, is it? For any epsilon you can find delta. If it happen, then we can say that the function has a limit, is it? What it means? This is again a distance between the two a and the point. This is distance between the L and f of x. As much as smaller epsilon, we can find a corresponding delta. Then we can say that the function has a limit. Then we say that the function has a limit. Getting this? That is, if we take any this, you can find delta. Is it? This is the definition of one variable. Similar definition we have to write here again. So how we write the definition? What will be the change? Two variable function. So it should be x and y, f of x, y. So x, y are there, therefore limit also may be 2, x tends to a, x tends to b, you can take. Is it? This limit is 1. Again same definition, just you have to write for every epsilon you can find delta greater than 0. With this, just you have to change this condition. This will be remain same. It is only f of x, y function of two variables. So how we write the definition? Let f be a function of two variable defined in domain D, which contain all nearby points of EB. That is, here domain we are taking D, is it? Which contain all the points, neighborhood points of A. So what we can say that? What we can say that then? Then we say that the limit of f of x, y is L as xy approaches to AB and is denoted by limit xy tends to AB, f of xy is equal to L if what? For every epsilon greater than 0 there is a corresponding, there is a corresponding delta greater than 0 such that all xy belongs to D and all xy belongs to D and 0 less than square root of x minus a square plus y minus b square less than delta, then what we can say that, then mod of f of xy minus L is less than epsilon. Again same definition, just there is a one change, that is neighborhood. This is the one change only. Okay, here is a real line, so here is a this. If you squaring both side, what we are getting? If you square here, then what we are getting, x minus a square plus y minus b square is less than delta square. It is less than what? Delta square. And what is this? This represent a circular neighborhood. What it represent? Circular neighborhood of circular neighborhood of AB. This is the circular neighborhood of AB. That means what circle, there is a one point AB and it is the set of all points whose, what we can say that, it is the set of all point whose radius, points inside the circle whose radius is delta. That means it is the circular neighborhood, and again it contains a 0. What it means, we can say that it is a deleted circular neighborhood. Neighborhood of AB we can show that n delta AB. So what we can say that it is n delta AB. It is the neighborhood of AB. What is it? It is the set of all xy where what we can say that the distance between x minus a square plus y minus b square is less than, should be less than delta. This should be less than delta. Is it? And deleted neighborhood, this is the deleted neighborhood. It is the set of all xy such that, again same definition, what, x minus a square plus y minus b square is less than delta, and one more condition will be there, xy is not equal to AB. Or you can write like this, or you can write, this is like all xy such that 0 less than square root of x minus a square plus y minus b square is less than delta. Is it? That is, it is just a distance between the all points, distance between the point xy and AB. Is it? What it represent? So deleted neighborhood and neighborhood you are getting. So so from this definition what we can observe, so we will write one by one. Note, I will write it is note. So what is first note? What it denote? All f of xy minus L. What it denote? It denote a distance between, what it denote? Distance between f of xy and L. It denote the distance between the f of xy and L. Second, what we can say? Again this, what is represent? x minus a, or you can write 0 less than x minus a square plus y minus b square is less than delta is represent a circular neighborhood of AB. So what is this? X minus a square plus y minus b square is a distance between points. Which points? X, y and AB. So this is the distance, this is the distance. Now what we can say that then the definition of limit says that if the distance between the points f of x, y and L can be made arbitrarily small by making the distance between x, y and AB small. Okay. So what definition says? Take very small distance or very small distance between the f of x, y and L. You can make it is very as small as possible. We can find a delta or sufficiently small distance between the point x, y and AB. What it means? You make small distance between these 2 points by making the sufficiently small distance between the x, y and AB. Okay. How we the diagrammatically shows? How we diagrammatically shows again? We know that what it represent? This is nothing but again f of x, y. It is belongs to what? L minus epsilon and L plus epsilon. Already I am giving this proof of this. So what means how we showed by arrow diagram? How we denote or describe it by arrow diagram? Suppose you have, this is the z axis and this is our f of xy. This is our f of it is our L. Then what we can say that take any epsilon. That is means what? L minus epsilon, L plus epsilon. Take any epsilon or neighborhood of L. You are able to find, this is our domain D. Then you are able to find a disk. We are able to find a disk of AB with the what we can say that disk D delta. Name is D delta, and this is, and all the points such that what? All the points of AB get mapped to the L minus epsilon to L plus epsilon. Is it? What can we say that what we are saying? Take any epsilon, then we get a neighborhood of L, and this neighborhood for this epsilon we get a disk D delta such that all these points of this disk will match or map to the L minus epsilon to L plus epsilon. Getting? And one more way of visualizing the definition, it is our graph. Again we can describe it by graph. How we describe this? Again same thing. Again same thing we have to do. That means what? Fourth one. Suppose this is our XYZ plane and this is our domain D of the graph F, and this is the surface S. This is the surface S, and if you take it is the neighborhood of D delta of AB, D delta. And what we say that if we restrict all xy in D delta, then the corresponding part of S, this should be like this. This is our L, this is our L minus epsilon, L plus epsilon. So what we can say, if we restrict all xy in D delta, then corresponding part of on S is lie between the plane. Which planes? Z is equal to L minus epsilon and Z is equal to L plus epsilon. Okay, this is our X, Y and Z. Okay. So what we can say that this is the graphical method visualization of a limit. So getting this? So limit, take any epsilon, you are able to find delta, then we can say that the limit is exist. Otherwise limit is not exist. Okay. So we will solve some example on this. So first example, using epsilon-delta definition, show that first example, limit xy tends to AB. This limit we can show this x is equal to A. Second, limit xy tends to AB, y is equal to B. And third, limit xy tends to AB, C is equal to C, where C is constant. So what I have to say, this limit can be shown, limit of xy tends to AB, or we can show that like this, limit x tends to A, xy tends to B, or we can show that this limit like f tends to L as xy tends to AB. That is, there are some different method of showing the limit of the function. Okay. So how we solve this? Solution. So first we have to show, to prove, what we have to prove? Limit xy tends to AB, x is equal to A. What is our f of xy? Here f of xy is equal to what? X. Our L is equal to what? A. Then we have to prove, what we have to prove, for every epsilon greater than 0 there is, what we can say, there is a corresponding delta greater than 0. There is a corresponding delta greater than 0 such that what we can say, that 0 is less than square root of x minus a square plus y minus b square is less than delta. Then what? Mod of f of xy minus L is less than epsilon. That is what? Put to f of xy is equal to x. So 0 is less than square root of x minus a square plus y minus b square is less than delta. Then what is our f of xy? F of xy is x minus L. What is L? L is our a, is less than epsilon. So that's what we have to prove. So how we prove this? Let epsilon greater than 0 be given. Epsilon greater than 0 be given. Then what we have? Consider mod of x minus a. What we can write? This is similar to what? Square root of x minus a bracket square. Is it? Can you write like this? Yes. Then this is strictly less than. What we can say? It should be strictly less than or equal to, what we can write? X minus a square plus y minus b square. Is it? It should be, suppose y 0, then it will be less than or it is equal to. If it is not, then we can say it will be greater than. Then what we can say, if we take, what we have to take? Now this is delta we have to find. So what we can say? So this quantity is there and it should be x minus a, this less than what we need, this less than epsilon. So what epsilon must be? Epsilon is equal to delta. If you take epsilon, delta is equal to epsilon, then we get 0 less than square root of x minus a square plus y minus b square is less than delta. Then what we can say? X mod of x minus a, this is equal to this, and this is strictly less than what? Delta is equal to epsilon, then it is equal to epsilon. Okay, so you can, suppose you have to write like this: delta, it is less than delta is equal to epsilon, and that is 0 is less than square root of x minus a square plus y minus b square less than delta. Then mod of x minus a is less than epsilon. Is it very simple proof? Similarly, you have to go for second one. Very simple, just replace x by y, you will get all the proof. So we solve the second part of this. So what we can find? We have to solve second. So to prove, what we have to prove? What we have to prove? Limit xy tends to ab, y is equal to b. Here what we have given? We have f of xy is equal to what? Y, and L is equal to what? B. Then we have to prove. What is the definition? For a given epsilon greater than 0, we have to find we have to find delta greater than 0 such that what we can say? What we can say 0 is less than mod of x minus, or what we can write, it is x minus a square plus y minus b square is less than delta, then mod of f of xy minus L is less than epsilon. Put the value of L and L and f of xy. So 0 is less than square root of x minus a square plus y minus b square is less than delta. Then what is f of xy? It is y minus b is less than epsilon. Similar proof is there. What we have to consider? Let epsilon greater than 0 be given. What we can write therefore, or consider mod of y minus b is equal to, what we can say, it is equal to y minus b square, is it? And this should be less than or equal to what? X minus a square plus y minus b square. Okay, so if we take delta is equal to epsilon, then we get, what we are getting, y minus b is strictly less than or equal to x minus a square plus y minus b square is less than delta is equal to epsilon, and this implies that what we can say, mod of y minus b is less than whenever square root of x minus a square plus y minus b square is less than delta. Okay, and therefore our answer is there. Therefore we can say that this has a limit b. Okay, very simple. So you can solve this. Third one, how we can solve? Just I am giving changes here. Is it? You have to try it for you. What is here? This should be c. This should be c. Then what is f of xy? This is c. This is our c. Then we have to for every epsilon. Similar thing is given. Is it? And here what should be this? What should be this? This is a minus what is c minus c. This is c minus c. So how we solve this? How we solve this? Consider or let epsilon greater than 0 be given. Then for any delta greater than 0, okay, we have what we have? C minus c is equal to 0 is less than epsilon. Therefore we get what we get for given epsilon greater than 0, we get a delta, any delta greater than 0 such that what we can say, that 0 is less than square root of x minus a square plus y minus b square is less than delta. Then mod of c minus c is less than epsilon, and therefore our limit of f of xy tends to ab, c is equal to c. Limit of constant function is itself. Okay, so getting this, similarly we can solve the some other problems. Like this is in the next lecture. So thank you very much.